Hi there, good afternoon. Daniel Call here from Surgical Holdings. Welcome to our first webinar of 2021, which is an introduction to electrosurgery. Thank you very much for joining us. I'm joined by Yuri, and Yuri works alongside me for the Bovie range through Symmetry Surgical. We've had a couple of technical issues, so I'm going to be Yuri's clicker on his slides. I think there's quite a few people on who have an interest from different areas of electrosurgery, some perhaps on the sterile processing side of things. So hopefully we can give some commentary that will appeal to both. Yuri, would you mind just giving a bit of an introduction for yourself, please?
Yeah, thank you, Daniel, for organizing the event. So my name is Jiri Madanen, and I'm the Symmetry Surgical Energy Portfolio Sales Manager for Europe. So energy portfolio is basically what we call electrosurgery in our company. And I work with our dealers across Europe, and Daniel amongst others. And Surgical Holdings is one of our most reliable dealers when it comes to electrosurgery. So thank you for organizing this event, and I'm really looking forward to discussing further. And if you have any questions, just type them to the chat as we go along, and I think we're going to handle the questions towards the end of the presentation. But please ask all the questions you might have while we're doing the presentation. So yeah,
great. Thanks, Yuri.
Yeah, I guess
I'll take you on to the first slide there, and yeah, just you can pick up there with some of your goals for today.
Yeah, basically, should we drop the cameras because we had some technical problems?
Yeah, sure. Let's drop the cameras. There we go. Okay.
So and please, if you're not hearing me right, please mention that in the chat as well. So our goal for today is pretty simple, actually. We would like to introduce the basics of electrosurgery to everyone attending the call. And I know as a topic, it can be somewhat intimidating because the field is very large and it's constantly growing and developing. And also there's a couple of things you need to understand from electricity and how it behaves, but let's keep that to a minimum. So in essence, what we're going to go through today, understand the fundamentals of electricity that have an effect in electrosurgery. We hope that after today you will understand the basic terminology, that whenever somebody speaks about electrosurgery, you'll be able to join and understand that conversation. And then we're going to talk about monopolar and bipolar electrosurgery, and those are two different things, and we're going to explain them. How are they different things? And then basically you will also get a basic understanding how electrosurgery affects the patients in the operating room. And although we know and understand electricity, there are still some safety measurements that we need to consider while doing electrosurgery. But in essence, it's fairly simple, and ask all the questions that you would like to ask. So let's talk briefly about the history and where it all began. As you all know, heat and fire has been used as a form of therapy or healing wounds for over 500 years ago. It's a simple concept. You just heat a piece of iron with fire, press it onto the wound to stop bleeding. And although it's simple, it's a very effective way to stop bleeding. And later, we designed special medical instruments called cauteries to do exactly what the name states, basically. Cauterize arteries and stop bleeding. And the most important thing to remember from the history book is heat. Heat is something that we're going to talk about when we discuss about electrosurgery. But the actual history of electrosurgery started in the 1920s. So Boston, Massachusetts, that was the birthplace of electrosurgery by William Bowie and Harvey Cushing. But I mean, that's all the history we need to know. Heat, let's move on. So after the brief history lesson, we need to understand one key goal of electrosurgery, which is hemostasis. The origin of the word is quite simple. It means blood stop. So that's what we are trying to do and accomplish in electrosurgery. As you all know, excessive blood loss is a major surgical complication, and it's also dangerous for the patient as well. It makes everything more difficult for the doctor and creates challenges to basically achieve a successful operation. So you have visibility problems, the doctors can't see what they operate. Bleeding can cause a vasospasm, which means that arteries become more narrow and reducing amount of blood that can flow through them. And that's a whole new world of problems if that happens. And it basically helps both the patient and the doctor if we simply minimize the blood loss during an operation. So the important thing from this slide we need to remember is, and a key lesson in medical schools around the world, it's there's no point in surgery if the patient bleeds to death. So that's the thing from this slide. Dan, did you want to talk about the other?
Yeah, I just, I mean, for me, really, I suppose, just talking from the perspective of other people that might be listening, of course, you look at the surgical trays that you might have, you might be reprocessing or handling in the theatres, and obviously, I think it's just awareness that you've also got things like hemostats, and that's one of the things on a surgical tray. There'll be multiples of things like house to mosquito forceps and Spencer wells and things like that. But I think it's understanding that it's a combination of a solution, and that's why obviously you have these electrosurgical devices on the trays as well, which I think for me again is understanding which is which really, and why there are different, why there is bipolar and monopolar. But I obviously you're going to come on to that.
Yeah, of course.
Did you have something to add on this slide, or do you want me to skip on?
No, we can move forward.
Okay.
So basically, this is the only sales pitch we're going to give in this presentation, and that is why electrosurgery is important and why we appreciate you all attending this call. Electrosurgery is extremely popular and widely used. Roughly 80% of all surgical procedures are done in some way using electrosurgery. So we're talking about dermatology, plastic, endoscopic, laparoscopic, plastic surgery. A lot of areas are covered by electrosurgery. So this means it's present in every hospital. All hospitals require electrosurgical products. And as minimally invasive surgery are becoming more popular, that only increases the popularity of electrosurgery. I mean, previously, minimally invasive surgeries were done with a scalpel and a handheld cautery. But with the introduction of the electrosurgical unit or the generator, you have the cutting and coagulation in the same device. And new technologies, they appear constantly, but electrosurgery is still extremely widely used in hospitals and procedures. So thank you all for joining this webinar.
I think it's also the diversity, the different, obviously the different uses, isn't it? And when you're looking at generators from a sort of range of 10 watts all the way up to 300 watts, that gives a massive variation of what they can be used for and how they can be used as well.
Yeah, absolutely right. You can use small family clinics all the way to the operating room.
Okay, so now we're going to go on to understanding the fundamentals of electrosurgery and obviously how the effect of those on electrosurgery. Sorry, my slide of electricity even.
Yeah.
Okay.
So it's a little bit more technical, but let's try to keep it as brief and as simple as possible. So what we basically try to do, or electrosurgery does, is it utilizes the heat that is created by the flow of electricity. That's all it does is in electrosurgery. But the good thing about electricity is that it behaves in a consistent and predictable manner. We know how to operate electricity, so it's a good thing. And these are the two most important principles of electricity that you should know. And please try to remember these. So the first one is electricity always seeks the completion of the circuit. That basically means that you need a closed circuit so electricity can flow. If it's not a closed circuit, then electricity will not flow anywhere, and there will be no electricity flowing anywhere. But we're gonna discuss this in more detail in the upcoming slides. And the next one is that electrons take the path of least resistance to flow. Basically, it means wherever it is easy for electricity to go, it goes that way. So those two above mentioned facts are the most important things you need to understand about electricity and in electrosurgery. And with those, we can move forward, and you'll understand this world a whole lot better.
And that of course is the relevance to the maintenance of the kit as well, isn't it? And you know, and we're going to come to that a bit later on, but obviously that's safety wise, that's the very key points, aren't they?
Yeah, absolutely correct on that one. And this is some basic basic terminology that you might hear or will hear when talking about electrosurgery. So we're going to talk about volts. So basically, volt means the force that drives the electric current through circuits, wire, or tissue. So that is measured in volts. Power, the rate at which power is consumed is measured in watts. And in electrosurgical environment, that means that we have different watt generators. 10-watt generator is a small one used in family clinics, dermatology. 300 watts is something that we will use in an operating room setting. So that is something related to electrosurgery. Hertz is the frequency when alternating current is used. So hertz is the frequency that we use to measure that one. Nice to know and good to know, but we can discuss that in further. And then we have two types of electrical current that we use in electrosurgery. So there's direct current, and then there's alternating current. So first, let's discuss about direct current. Electrical current flows directly in one direction with a specific constant voltage. Basically, it means that electricity flows with a single specific pattern without any changes with the same force. As you can see in the picture, it just remains on the same level. And in electrosurgery or in this field that we're talking, electro-cautery is a good example of direct current. Then we're going to talk about alternating current. So next slide. Yeah, the second way electrical current is created is alternating current. So alternating current is the current that is used to power most electrical appliances in your houses, and basically all electrosurgical generators use alternating current. This means that electrical current is not a single constant voltage, but it's rather a wave. If you take a look at the picture, it goes up and down. And we can control this wave with different electrosurgical devices, and all generators use alternating current. So if you don't have anything to add, we can move forward.
Sure.
So a little bit more about alternating current. And please ask if you have any questions or put them in the chat. So alternating current, what it means, it switches the direction of the flow of the electrons or the electricity, and we use hertz as a way to calculate that change. And we all know that human body and nervous systems react to electricity. So the nervous and muscle stimulation stops at 100,000 cycles per second, which is 100 kilohertz. Basically, all electrosurgery is performed between 200 kilohertz to 3.3 megahertz. This is just to let you all know electrosurgery can be done safely without affecting the body in an undesirable way. So that's the main thing you need to take away from this slide. And just to remind you, alternating current means that electricity must have two poles in order to flow. It always seeks the completion of the circuit, but we can look at the examples in the next slides.
Okay, I'll take us on through. So now we're going to go on to electrocautery, monopolar, and bipolar surgery.
Yeah. So now we've discussed enough about electricity, how it behaves. So So let's move on to the main topic of the presentation. So we have electrosurgery. There are different types of electrosurgical generators. And as Dan already mentioned before, there are 10 watt generators, 40 watt, 50 watt, 120 watt, and 300 watt generators. They all use alternating current. And basically what we do is we cut, coagulate, or fulgurate tissue with the device. And the electrical current, it runs through the tissue always. Either, it doesn't matter if we use bipolar or monopolar, the current runs through the tissue always. And a term you might hear sometimes, but it's good to differentiate it from electrosurgery. So electrocautery, there are high and low temperature pens. So as we mentioned before, electrical current is used to heat the metal wire on the tip of the pen, and that tip is then applied to the target tissue, and then we're going to coagulate that surgical site. But the electrical current doesn't run through the tissue, it just touches the tissue. And as mentioned before, we use direct current in electrocautery. Yeah,
I think that's quite an important to distinguish between those two, because there is often an assumption that it is the same thing, but obviously they operate very, very differently.
Yeah, different mechanics and totally different use cases. So that's good to know. So basically, these are the common components. You see in an operating room or anywhere that electrosurgery is done. And this is something that might make electrosurgery somewhat of an intimidating subject, because there's a lot of different options available. But there's always the same things available. There are the generators, that's the source of the power. And when we look at the upper side of the slide, you have the bipolar forceps cord connecting to the generator, and you have 5 different bipolar forceps. So you have coated ones, you have non-coated ones, you have angled ones, non-angled ones, reusable, disposable. So there are dozens of different bipolar forceps to choose from. And generally, a bipolar forcep is activated through the foot switch. And if we take a look on the lower side of this presentation or the slide, you have different pencils. So that's the monopolar side. So you have reusable pencils and disposable pencils, and they attach to the generator. And then you have different types of electrodes that attach to the pencils. So there are needle electrodes, blade, ball, loop electrodes. Some are coated, some aren't coated. Again, reusable, disposable, different angles, different lengths. Again, dozens of different options, but they all belong to that part of monopolar electrosurgery. They all attach to the pencil. You can use the pencil, you can activate the generator from the pencil. You see the blue and the yellow button. So yellow is always cut, blue is always coagulation, and that trend continues in the foot switch also. You can activate the pencil using the foot switch. But what's different or what's additional to monopolar electrosurgery is the patient return electrode. So basically, we're going to talk that in more detail, but that's just another part of the portfolio. And then,
sorry, Yuri, I was just going to say, I mean, obviously, there are a huge amount of variations on there, as you said, on the things like the bipolar forceps, but people might also see particular tips, things like silver tips on these forceps, obviously, which are generally used for more delicate surgery, and angled forceps, and even, I know you're probably just going to get onto smoke evacuation now, but you're even got things like combination smoke evacuation electrodes and pencils now, haven't you? So it's developing constantly, isn't it, this area?
Yeah, it's a really good point. It's constantly developing. We're constantly creating new products to this area. So that's probably one of the largest reasons for the confusion. but they always have that same place in the generator and in the surgery. It's on the tip of the, basically on the pencil or the bipolar forceps themselves, but there are tons of different options. And you already started about the smoke evacuation. So basically, what we're using in electrosurgery is we're using heat on tissue. So there will be surgical smoke, and surgical smoke is dangerous. So it's we're seeing an increased demand for smoke evacuation system. So that's one common item you will see in the operating room as well when we're talking about electrosurgery. But in essence, that is the major components when you are doing electrosurgery.
Sure, and of course the other thing to mention around the colours, the yellow and the blue. If it's something that people are seeing on pencils and wondering what that corresponds to, I know some of the pencils will have cut, which is obviously related to the yellow and blue obviously on the other side of things. But well, I know you're going to go on to a bit more on the generators itself, but there's a huge amount, obviously, of different functions with those pencils as well, aren't there? And I just wanted to, the reason I'm flagging it is I saw a question come up that's probably quite relevant. I just wanted to mention now, rather than at the end quickly, fulguration. Kim has mentioned what fulguration is, and I don't know, Yuri, if you wanted to take that now, or is
we can do that later, because that's a different term that we're going to do later on.
Okay, cool. All right,
so we're going to have an entire slide about that one. So now the difference between monopolar and bipolar electrosurgery. These are two most common terms you will be hearing when talking about electrosurgery. So what is bipolar electrosurgery? Basically, the components are the same. You have the generator there. That's the source of the electricity or the electron flow. Then you will have the instrument, the bipolar forceps, and those are connected to the generator with the cord. And basically, if you remember, electricity always seeks to complete the circuit and seeks to find the path of least resistance. When we're using bipolar electrosurgery, the circuit is closed between the tip of the forceps, and that happens to be the path of least resistance to close the circuit. So that is really a safe, precise way of using electrosurgery. And then you obviously have the patient, and as mentioned before, the current runs through the tissue that's grabbed between the forceps. So it doesn't stay on the tissue, it runs through the tissue. And you don't need to use any return electrodes when we're talking about bipolar electrosurgery. So only these components. And as mentioned before, oftentimes bipolar electrosurgery is activated with a foot switch, but it's possible that it's also automatic. So when you use the forceps, it senses automatically that there's tissue and starts to work. And Dan, if I forget anything while we're going, just jump in and do your thing.
That's perfect. Yeah. Oh, there we go.
Yeah. So basically, advantages of bipolar electrosurgery. So it's really good for neurosurgery, ENT, OBGYN, minimally invasive surgery. Why is that? It's really a controlled pathway. We know that the energy is delivered through the forceps. It's not going anywhere else. So that means also that there's the electricity doesn't cause any other thermal damages outside of that area. And because you don't have to use a return electrode, let's say if you're operating an ENT operation, you would have to place the return electrode if you're using monopolar mode somewhere close to the surgical site, but that means the electricity is still running through the body for a longer period of time to get to the return electrode. So bipolar is more precise, and you don't have to worry about patient return electrodes when using this. And we're seeing an increasing popularity when we talk about bipolar for electrosurgery. More and more instruments are developed for bipolar only, and even in our portfolio, we've seen a tremendous increase. So that's something that's the doctors are more and more interested in right now.
I think it seems to be obviously there's the specialist applications, but generally on most surgical trays in the UK, you'll see a sort of combination of the two, of the monopolar and bipolar. You know, even just for the basic forceps. So obviously, as you say, that you know, the use of that popularity-wise has increased.
Yeah. So after bipolar electrosurgery, let's discuss monopolar electrosurgery. So basically, electrosurgery started with the monopolar mode. That's one of the reasons why monopolar electrosurgery is still more common and it's widely used, because it's extremely versatile and it's really effective. And as we in the previous slide we already mentioned, there's tons of different tips for different types of operations. So monopolar electrosurgery is extremely versatile. So when we take a look at the components in monopolar electrosurgery, again, the generator is there, source of power. Then you have the active electrode. So that is the pencil and the tip. And basically, the flow of electricity is transferred from the pencil to the tissue. And then you have the patient, and the current runs again through the tissue. But now we need to think about where to get the path of least resistance and where will electricity return to close the circuit. So that's the reason why we have to use the return electrode, basically. If we don't have...
if you were, sorry, I was just going to say, I think if you were obviously new to the industry, or just even as a patient going into operation, you'd probably be quite shocked to know that you have obviously current running through you as part of an operation, wouldn't you? It's, you know, so obviously safety of that is paramount.
yeah, I mean, yeah, that is absolutely true. But that's the reason why we have to use the return electrode, because if we don't use the return electrode, the OR table is a really good other pathway to catch the electricity. And if it goes down that way, we don't know what kind of damage we're going to do for the patient. So it's an absolute safety measurement, and that's the only thing separating bipolar from monopolar. In monopolar, you have to use the patient return electrode. Yeah, so let's discuss a little bit more about the patient return electrode. So in essence, the purpose is to safely remove all current that is delivered to the patient during the monopolar operation. So ideally, the placement must be on a tissue as close to the surgical site as possible, but not on a bony prominence, because then it's not the path of least resistance anymore. And what's important, that you need to make sure the return electrode covers large enough of an area to remove the electricity and return it back to the generator and basically close the circuit. So that's what it does. Previously, in the past times, we used metal plates and an active gel on top of the plate to catch the electricity back, and that's very commonly used in animal health still. But currently, there are more developed return electrodes for human health, because those are split electrodes that monitor actively if the return electrode is safely placed on the patient. If it's not safely placed on the patient, then you're not able to operate on the patient. So that's a safety measurement, and that is constantly developing as well. So bipolar is developing constantly, but monopolar is developing at the same time.
I think that's probably a bit of a relief that those safety mechanisms are built in that case. And of course, you see huge variety of the different types of plates as well, don't you? Different shapes and sizes that are suitable for, you know, for adults and children.
Yeah, and it tackles basically the most dangerous part of monopolar electrosurgery. So you can do a lot of damage if you're not careful with this one. But we did have a question about fulguration, I guess.
Yeah.
Was one.
Yeah.
So basically, these are the most common words you can hear or will hear, and the actions that doctors perform on a patient. So simply, you can cut with the device. It means divides or penetrates tissue. You can coagulate and desiccate. So basically, it means that blood turns from a liquid form to a gel in order to stop the flowing. So coagulating and desiccating means the same thing. Then you have blend mode. So that's in between of cutting and coagulation. And that's good to remember when we're going to go through the generators and different waveforms. And am I remembering correctly? Was it fulgurate was the question?
That's right. Yeah. Yeah. And it was, I think, because I was going to say, obviously, where you have yellow for cut and, you know, blue, is assumed that that's coagulation, but there's so much more depth, isn't there? And obviously, as you're explaining.
Yeah. So basically, when we talk about fulgurating, it's the easiest way to explain it. It's non-contact coagulation. So fulguration means if you have a heavy bleeder, you use the coagulation mode, but you spray it on top. So it basically coagulates a lot larger surface area, and you don't have an actual contact to the skin when using fulguration mode. So those are the basic terminology and activities what we do with an electrosurgical generator.
Okay.
And I understand that this slide is a little bit crowded. I tried to make it as small as possible and without doing any double slides. But let's keep this simple. Basically, there are different waveforms, and what a waveform does, it describes as what type of flow of electricity is created to the tip of the instrument. So that's what a waveform basically represents. What kind of electricity are we using there? And as we talked before, alternating current is a wave, and we can control the wave with the generator. And how do we control the wave? If you remember from before, we talked about heat and time. The only variable that determines whether a waveform cuts or coagulates tissue is the rate at which heat is produced. So the only thing we control is heat and time. So when we talk about cutting waveform, a cutting waveform is achieved when we use constant high heat and we create it at a rapid pace. So there's no room for hemostasis. The blood will not turn to a gel mode. So that's basically what cutting is. Rapid heat, high heat produced rapidly. And then we briefly talked about the blending on the previous slide. So depending from the generators, but the larger generators have modes in between to perform more specialized surgeries, and those modes are called blend mode. Although those are blend modes, they are still cutting modes. You will achieve cutting as an end result when using a blend mode. So when you look at the blend 1, you produce heat, and then there's some time between. And as you go to blend 2 and blend 3, the only thing that changes is the time in between. So blend 1 will have less coagulation than blend 3. Sorry. And then the final mode that we're going to talk about is coagulation. So coagulation waveform, in essence, it means that low heat is created with long intervals of time. So then the blood actually has some time to get, it has time to coagulate. So again, the only thing that is changing in cutting and coagulation is the heat and time that we produce it.
Okay. Want to skip on?
Yeah. And sorry, it's minus 23 degrees here where I live right now, so it's I need to stay hydrated and warm. So here you will.
I thought it was cold in England last week at like -2. So
yeah, but I mean, I'm used to this. But I mean, my colleague in Houston, Texas, they're not used to that weather. So I'm doing okay here still. So we can continue. So here you will see what kind of an impact electrosurgery has on the tissue. So if we look at it on the picture above, you can actually see that it's the coagulation mode and blend modes. The tissue becomes more dark as heat is produced in a different way. And when you use pure cutting, then it's actually just divides the tissue, penetrates the tissue, and there's very little coagulation involved. There is no coagulation involved. You just go right through the tissue and you cut it. And obviously the following things also have an impact on the end result when you use electrosurgery. So how much power do you use? And a good rule of thumb is start at the lowest possible setting and slowly increase the further you go to get the desired effect. And similar to the first one, application time. It's always better to use brief intervals, recurring activation, than longer periods of time holding on the tissue. So start small and slowly grow from there. Obviously, the shape of the electrode. So we had needle electrodes, blade electrodes, loop, and ball electrodes. So the surface area of the electrode itself will have a tremendous effect how the electricity will be transferred to the tissue. Tissue properties will have an effect. What area are you operating? So if it's more moisture, then you will probably need to use more power. And different doctors use different techniques. They're taught the different ways of doing the same thing. So surgical technique also has a really big impact on the end result and how it looks on the tissue.
I mean, that was something that's a bit of a surprise to me when you were learning about it, because I think there's an automatic assumption that the delicate areas you're going to have less power, but certain obviously urology procedures where there might be moisture or sort of saline involved and things like that, obviously higher power is needed there. So there's not always an obvious solution in terms of the tissue and how that would be approached.
Yeah, no, you're absolutely correct. In urology, you need higher power, so that's absolutely correct.
Okay.
And here's just a typical list of some examples. What kind of power settings are used in procedures? It's not all inclusive, and there might be some changes, but dermatology, plastic, oral surgery, generally done. A lot of surgery are done generally with low power. General surgery, ENT, that stuff, it's medium power. And high power, and as you mentioned in the previous slide, for example, if you perform a TURP, then you would actually need to use a lot of cutting power because there's more moisture involved. So you're absolutely correct on that one. And although it's a list of procedures and all different procedures are done with different power settings, fortunately the doctors know what settings to use, so we don't really have to focus on this one. But the most important thing from this slide, you will have to remember that oftentimes it's not the surgery itself that will require a lot of power. It's actually the potential bleeding or blood loss that you're going to have to stop. So that's why you need to use a lot of power, potentially use a lot of power. So whenever you coagulate and you have a heavy bleeder, then you're going to need to use potentially a lot of power. So not the surgery, but potentially the bleeding.
Okay, that's useful information when you sort of see the power ranges there that are recommended, and obviously knowing that the machines go up significantly higher than that.
Yeah, and I still see it because in the past Eastern European countries, our units go up until 300 watts, which is operating room standard. but some Eastern European countries would like to have 400 watts of power, but I honestly don't know where you need to have 400 watts of cutting power. I think you can almost cut through a wall with that amount of power. So it's something that some electrosurgical units were 400 watts in the past, but generally that's really high right now, and usually they stop until 300.
Okay.
Yeah, and we're still talking about electricity, and although it's predictable, there are some safety considerations that need to be handled. And as mentioned before, the surgeon will always tackle a lot of problems by using the first one. Start at the lowest possible power setting and slowly increase. That's by far one of the most important things when using electrosurgery. Daniel, do you want to tackle the next one?
Yeah, sure. Sorry, I'm just trying to see the screen through my questions. Yeah, I mean, so things obviously, this is really, I guess, onto the safety side of things, of inspection and of the devices that are being used with the surgeries. And I think the obvious thing is not having a hole in them. They're insulated to protect that flow of the current and to ensure that it takes the right path through the plate, and obviously that there aren't any dangers there whereby there could be. I mean, I think the obvious ones to look at are the smaller forceps, so the smaller monopolar forceps, which are just the sort of general surgery. And you can often easily see the nicks in those, where there are holes in those, or there's insulation damage, or there's damage on the tip. But of course, breaks in the insulation on your longer instruments, sort of the laparoscopic instruments, that perhaps you're not going to be able to see when you're operating completely, which is obviously a danger there. That you're talking about their direct coupling as well. Again, this is direct coupling and capacitive coupling. You've got a scenario where you've got the instruments being used. You can't really have a full picture of if there's damage to that instrument, if it's potentially burning the inside of somebody, in a minimally invasive operation. So I think it's really awareness there that anything that's being used in the operation should be checked thoroughly for nicks and for damage. And of course, you can get. It's not only that, the devices can be particularly difficult to clean on the tips as well. So, I mean, that's something, Yuri, that you'd advise using sort of pads while the devices are being cleaned to ensure that the pentacles are clean.
Yeah, there's a different type of a cleaning pad, so to say. When you have it's called eschar, when you have burnt tissue on the tip. So it's a special pad that it's really good for the instruments. So we prefer to use that one, or to sell, and our users to use that one because it's safer. And as you mentioned, it's if you actually listen to from this slide, start at the lowest possible power settings and brief activation. And then if you make sure that all the equipment is up to par, it's not damaged. If it's damaged, go to surgical holdings and get new ones instead. But you're gonna end up minimizing a lot of risks just by doing that. Carefully inspecting the equipment, and basically use bipolar electrosurgery when you can. So that's one thing as well, because of the controlled electricity flow. And and as mentioned before, surgical smoke. We're seeing an increased demand in surgical or smoke evacuators in Europe. And I live in the Nordic countries, so in a lot of places it's illegal to operate using electrosurgery without smoke evacuation. So it's getting more and more pressure in every country to actually take care of the surgical smoke with our smoke evacuation systems.
I mean, that obviously, I think with COVID, that has become obviously an increasing area of awareness. Just before we move on, I just wanted to mention, just going back to the things like the blowholes in the instruments, and the is that obviously you can look at them, and I think that the main recommendation is just to look at them with the naked eye. But there are of course testers and testing units you can buy that can obviously ensure that there's some assistance there, that you're checking the sort of classic sort of electricity game with essentially the principle's the same, where you're putting current through and putting the forcep in, and it will flag up and buzz if there is an issue on that. So I think that's really, really important, particularly on the laparoscopic instruments, because as I mentioned, that's a hidden danger there. And yeah, just to be aware of the issues with coupling, and that if you've got a stainless steel instrument and you've got you're using it alongside an instrument that obviously has electricity running through it, I think it's a natural thing for there to be a cautious approach there, because of obviously, as we know, the current taking the least resistance.
Yeah, absolutely correct, especially with the laparoscopic procedures. Absolutely correct on that one. Yeah.
So I'm just trying to click us on there in a moment. There we go.
So basically, I just wanted to wrap up this brief presentation and go through our goals, and hopefully we all learned something new today, and then we can tackle the questions. So understand the goal of electrosurgery. It's quite simple. Perform a successful operation on the patient and minimizing bleeding. That's what it is. In essence, that's what electrosurgery is. And what we use in electrosurgery, heat and time are the main agents to achieve coagulation and minimizing bleeding. So that's about it. Understand fundamentals of electricity. So there's only two: and completion of the circuit, and take the path of least resistance. And we discussed that differences in monopolar and bipolar electrosurgery. So those are the two major things you need to know about electricity in the context of electrosurgery. Understand basic terminology. Electrosurgery is the generators, different surgeries. Electrocautery is the pen that uses direct current. Then you would know generator, what's the electrode, the pencil, forceps, return electrodes, etc. Know the basic components, what do we have in the OR. And then cutting, coagulation, blend mode, and fulguration. Those are the things that we do with the device. So cutting cuts through the tissue, coagulates, stops bleeding, fulgurate, spray coagulation, so non-contact coagulation. And then understand the difference between monopolar and bipolar. And it gets confusing, but it is fairly simple. The forceps, you have two poles to close the circuit, so that's bipolar. Two poles are in the forceps, so that is bipolar surgery. Whenever you have monopolar electrosurgery, there's only one pole, that's the electrode, and then you have the return electrode to close the circuit, and that's the second pole. So you have two items to close the circuit. So yeah, monopolar, that's monopolar electrosurgery. And then understand what kind of effects this has on the tissue. So, and you saw the cutting and the coagulating, but you can obviously, we're going to send you the slides so you can see them as well, and the safety measurements that we just went through. But I mean, I'm sorry if I missed anything, but right now I feel like that we've gone through everything.
Yeah, I think we've got, that's a really good summary. So thank you for that, Yuri. I think as an introduction, I think maybe hopefully further down the line we can try and do some demonstrations involving some of the machines to show the differences, because I think you can only really appreciate the functionality differences by sort of seeing them live, particularly like fulguration, and it is literally a spray. I think that's probably the best way you can sort of describe it. But yeah, I mean, obviously safety considerations very, very important to ensure the instruments and the patient sort of safety pathway, I guess, from use to cleaning and back round to use again, that that they're sort of checked thoroughly and are obviously clean. There are we've got a couple of questions that have come in there, and please, if anybody else has any others, please put them in the chat. My browser isn't responding too well, but I hopefully will pick up some of these. So Yuri, first off, Tim has just asked for a repeat on the kilohertz range for electrosurgery. I think we discussed it earlier on. I think he means that obviously where it becomes safe, the range of kilohertz.
It becomes okay. So basically, electrosurgery is performed between 200 kilohertz to 3.3 megahertz. So that's the range we use when we talk about electrosurgery. And nervous and muscle stimulation stops roughly at 100 kilohertz. So that's just basically, it's detailed knowledge, but I mean, just to prove that electrosurgery is safe in that sense. But that's a really good question, because that was one of the first questions I had also in my mind when I had the first lecture on electrosurgery.
Yeah, it's obviously it's so complex, and understanding how that current can be run through the body and for it to be safe is I guess can be quite confusing. In fact, so let's have a quick look. I'm just trying to see what else we've got here. So Lisa has said that from their point of view, on their for their business, they're phasing out the use of solid plates now. So I presume that some are still being used in hospitals across the UK, but obviously because of safety concerns, and there are other options as well. We see some of the bigger sort of mats, the reusable mats that are the sort of soft patient return plates. So there's a massive diversity in that. So I think it's, if you were looking at the picture of that small patient plate and then comparing them to some of the market, it's a huge range, aren't there, out there?
Yeah, and it's a good comment from Lisa, because I didn't want to give the impression that metal plates are used in animal health and split plates in human health, because that's not the case. I mean, in the past, metal plates, those were the only option. And for example, the split return electrodes, those have been developed, and those are the ones that the generator actively monitors that the return electrode is safely attached to the patient. But that being said, those are more expensive as well. I mean, there is a price increase, and many times it's a budgetary thing as well. And sometimes it's even not a budgetary thing, but oftentimes I do get dealers and end customers that prefer using metal plates because that's what they've been using, and they know how to use them as well. I mean, I'd rather them use the split electrodes for safety consideration, but at the same time, the people who are using the metal plates, they absolutely know how to use them as well. So it's not black and white. I mean, as you mentioned, there's a lot of different options there. But I mean, a good comment from Lisa. Those are popular still.
Yeah, I think understanding that diversity is a challenge, I guess, when you're looking at and understanding what's out there, what's the safest thing. But I think the reassurance is on the generators and on the modern generators is that if there is that slight the adhesion for the patient plate to the patient, if there's a slight disturbance in that, that obviously the machine will automatically sound and shut off. So that's got to be a fairly a good reassurance in that respect. There's a comment from David Jagrosi, and David's saying that he's got a statement about the new AAMI standard, which I think is a standard from the States. I'm not familiar with that, and David, if I could actually work out how to put you on audio, I would, but I think there's a fair chance that if I try to do that, I'm going to ruin the whole thing. So if you wanted to update a bit more information on the chat, then I'll try and it'd be interested to hear what that update is, or of course send over to us after, and we'll try and answer that.
If there are questions, I mean, we can always gather them to a single email and share the slideshow, the presentation, and answer all the open questions that you might have. So yeah, that's always an option.
Okay, great. And Tim's very satisfied with your answer. Okay, right, great. Here we go. So David's kindly updated his question here. So amendment A2, amendment of inspection of insulated instruments requires testing and inspection of insulated instruments. This includes in sterile departments. So I think David's obviously picking up what I've said, and it sounds like it's sort of becoming mandatory in certain parts of the world for these instruments to be tested. And you would think, on the basis of the damage that could occur, just to obviously to patient or obviously to surgeons or to our ODP staff, that seems like a very sensible step there. So thank you, David.
Yeah, it's a step to the right direction, of course.
Lisa's just got another point. She said she's obviously heard about electrofulguration. Argon plasma, is that something you're familiar with, Yuri, as a procedure?
Plasma, we don't have that in our portfolio. So I know
about
it, but
you don't want that then, Lisa.
Yeah, electrosurgery. I mean, I would love to discuss that in more detail, but yeah, I mean, we don't have the energy portfolio that I represent. It's called the Bowie Medical Portfolio. So William Bowie was the first one to invent electrosurgery. So our line of electrosurgical devices are limited to electrosurgery, but we don't have plasma, unfortunately.
No. Okay, there we go. Okay, well, we'll wrap up there. Thank you everybody for listening. Thank you, Yuri, for that great presentation. And I'm sure there might be more more opportunity for doing some other stuff and maybe some live demonstrations further down the line. So great. Thank you, everybody. Stay safe, and we will, if you're interested in any of the other webinars that we've previously done, there I'll share the link with a follow-up email, because there's some others we've done on instrumentation, laparoscopes, flexible laparoscopes. So hopefully they will be of interest. But thanks everyone. Thank you, Yuri.
Thank you. Yeah, thanks on my behalf as well for joining the webinar. And if there's anything more you would like to discuss about electrosurgery, please contact Daniel, and we can most definitely arrange something as well if it's interesting to you. So thank you all.
Fantastic. Oh, hang on, sorry. There is one final question. Actually, I can follow up on that with somebody directly. So no problem at all. Okay, great. Thanks, guys. Good afternoon. Bye.
Stay safe all. Bye-bye.